In the other video on 1.2, we discussed classifying real numbers as either rational or irrational. In this video, we'll talk about properties of real numbers, as well as go into 1.3, just an overview of what an algebraic expression is, as well as all the vocabulary that is tied to algebraic expressions. So to begin with, commutative property is when there's a column for addition and there's a column for multiplication. So I'll go ahead and divide the paper that way. So if we have a number plus a different number, that's equivalent to if we swapped the two numbers. So think commutative has the word commute in it, which is to travel. So A plus B, let's say that B traveled to the position of A. So we've effectively switched the two. And then with multiplication, a number times a different number equals that different number times the original number. So again, switching A times B equals B times A. Associative has the word associate with it. So with addition, if we have three numbers that we're adding together and we have a quantity of A plus B plus C, well, with addition, associative says that if we remove the parentheses and the association and reapply it to B plus C, that the sum of the original one, where A plus B has parentheses around it, is equal to the second sum, where you have B plus C with the parentheses around it. Same goes for multiplication. So A times B quantity times C is equivalent to A times B times C, where the parentheses goes around B times C. The identity process is, the property is with addition, what can you do to a number, either through addition or multiplication, such that when you apply that operation, you maintain the same value A. So what can you add to A and still get A? Well, that value is 0. So the identity property just simply says if you add 0 to a number, you still get, you don't change the number in any way, you still get the original number. Now ask yourself for multiplication, A times what number would leave the identity still at A? And that would be times 1. So with addition, it's adding 0, the identity property, versus with multiplication, it's it's times 1. The inverse property is undoing. So if I have A, what would undo positive A such that I would get 0 as an answer? And that would be same thing as subtracting A or adding a negative A. In terms of multiplication, the inverse property would be what would I multiply A by so that I would effectively undo the quantity A, and that would be times 1 over A, and that will undo so that your answer is 1. Okay, distributive property we've seen over and over. There is no addition. It's kind of a bridge between addition and multiplication, but you have A and then times the quantity B plus C is equal to, we would distribute the value of A to B and the value of A to C. So A times B plus A times C. Now the opposite is also described as the additive inverse. So the opposite of a number is like, if for example positive 2 would be negative 2. And we can ask ourselves, well, what would happen if you add the opposite? It would undo so that we would get 0 as an answer. So the opposite or additive inverse of any number A is negative A. The sum of the number and its opposite is 0, which is called the additive identity, which we summarized above. The reciprocal or multiplicative inverse of any number is 1 over that number. So if I take a number and then I invert that, I get the multiplicative inverse, and the product of the original number and that reciprocal is equal to 1. And that's again called the multiplicative identity. And when would we use a property? Well, as we move into expressions and equations, when we're solving an equation, we would apply the additive inverse so that we can isolate 3x. So might not think of it in such formal terms, but to undo the positive 2 and isolate 3x, we would subtract 2. And so we're adding 2 and its additive inverse, or its opposite, so that they undo each other. And we get 3x equals 6, or in other words, x equals 2 as a solution. So under 1.3, I just wanted to cover some vocab with you guys. When we're looking at an example like 4ax plus 6x squared minus 4 minus 4x squared, in this class I want you guys to be proficient and fluent with the vocab. So with term, we're looking at the above as an example, and it's any expression really, but an expression that is a number. Could be a number, it could be a variable. So an expression that is a number, a variable, or product of number and variable. So an example that we'll just add to this, and I'll make it a different color for my examples here. So the example would be 4ax above is a term. So anything separated by addition or subtraction is a term. Or you can say 6x squared is an expression, or 4 is an expression. The coefficient, on the other hand, is a number in front of a variable expression. So it's the numerical factor. Of a term. So if we look at our example above, we see that 4ax, for example, the coefficient for 4ax would be the number in, the numerical factor is the number that's in front of the variables. So our example for that would be 4 or 6 in the second term for 6x squared. Constant term, and students get those two terms confused, coefficient and constant term, but a constant term is a term without any variables, with no variables. So if we look at our expression above, we have only one term that doesn't have any variables, and that's negative 4. Like terms are terms with the same variable, and it has to be raised to the same power. So like terms are terms with same variable raised to the same power. So take a look at the above, and I want you to pause the video and tell me if there are any like terms.